This is the Building Automation Monthly Podcast with Phil Zito, episode 105. Hey folks, Phil Zito here, and welcome to episode 105 of the Building Automation Monthly Podcast. In this episode, we are continuing our conversation around control sequences. So in the previous episode, episode 104, we dove into control sequences at a very basic level. We talked through what control sequences are and where they reside. We talked through the three-step process for working through control sequences, why focusing on control sequences flow is critical to success, and how to understand a sequence no matter how complex it is. So I really, really encourage you, if you haven't already done it, to listen to episode 104, because if you don't, this episode probably won't make as much sense. So I encourage you to do that prior to listening to this episode. With that being said, though, to the rest of you, welcome to the second part of this series. So in this episode, we are going to be discussing the three strategies for dealing with sequences. And what I want you to do with this episode is to realize that whereas a lot of my past episodes have been very situationally specific, this episode it's a little different. How do I say this? Basically, what I'm saying is you got to think for yourself. I don't know any other way to say it. What I'm going to teach you in this episode is taught in such a way that you can use what I'm going to teach you in multiple different situations, but you got to think for yourself and realize if the situation is right to use these tips or not. So the first one, and this is something that I suggest to almost everyone, and a lot of folks will look at me like I'm crazy when I suggest this. And you'll understand instantly as soon as I say it. So it's to think like a programmer. Now you can imagine when I tell a salesperson or I tell a design engineer to think like a programmer, they look at me like, okay, I've never programmed anything in my life. How do you expect me to even think like a programmer? Well, that's kind of where this tip is going to come in handy. So what I want you to do whenever you're looking at a sequence, and if you're in sales, let's tackle that one first, right? So you're a salesperson. You come along a sequence of operations because you're developing a scope and an estimate for a project. What I want you to do is I want you to think about, as you look at this sequence of operations, what would be needed really to go and actually execute a project? And if you're like, still, Phil, I don't know, then this is pointing to a big gap in your skill set. I know, you probably don't want to hear this, but the reality is if you want to get really good at estimating, yeah, relationships are key. Don't get me wrong. It's important to have relationships, to have relationship skills, to be able to identify stakeholders, to be able to have sales strategy. That is all really important stuff. But where I see a lot of salespeople start to have gaps is where they don't understand kind of what goes into actually installing a BAS. And so I really recommend, if you haven't done it yet, that you go out on a job site and you shadow someone for a day or two and just see what they're doing during the install process. So with that being said, assuming you've done that, assuming you understand what happens during in the install process, I mean, the first thing that has to happen, right, is you've got to have inputs and outputs. So as you're looking through this sequence of operations, as you're looking at this, maybe it's a set of mechanical plans with a sequence in it. Maybe it's a specification, but you're trying to build your scope. You got to first identify the inputs and outputs. I've seen too many scopes where inputs were missed or outputs were missed, specifically interface inputs. So for example, a BACnet IP interface to a rooftop unit. I've seen that missed, and then because of that, it adds several $1,000s to the project that didn't need to be there. So the first thing is, how are you going to get information to the controller? How are you going to get information out of the controller? That is inputs and outputs, right? So sensors, pressure sensors, flow sensors, temperature sensors, that's all inputs. actuators, relays, interface cards, those are all outputs. And so that's what you want to look at. That's your first thing, inputs and outputs. Then once you've done that, you can look at how is the system being controlled. And this is kind of a rule of thumb that I've used. Once again, I said this isn't going to be specific to any single situation, but use this kind of, I'm thinking while I'm talking here, use this kind of as your guide. And what I mean by this is, so if you look at a sequence and it's fairly simple, maybe it's a rooftop sequence and it's install BACnet IP interface card, schedule occupancy on and off, turn set point on and off. Then when you think about your labor for a specific project, the labor for that's going to be a lot less than if you look at a air handler sequence and it's talking about you've got a fan wall that you need to control. You've got exhaust and return VFDs, and those are going, and they are actually in a control sequence where you need to compare the two, and then you have airflow monitoring stations, and oh, by the way, you have an enthalpy wheel, and you also have a building static strategy that is tied to these exhaust fans. You're starting to see where I'm going. That is going to be a much more complex sequence. While the points may be very similar to the points on a standard air handler, it's the complexity of that sequence that I want you to look at. So I want you to think like a programmer, thinking like, what would I have to do to make all this happen? You may not, well, I'm not even going to say may, you don't need to know how to code that. If you're in sales, if you're in engineering, I mean, if you're a tech, you really should. But if you're in sales or engineering, you don't need to code that. But you do need to understand what it means to have all of that complexity, because that complexity is where I start to see jobs get under budgeted. And then, you can make the choice. At least you can make an educated choice. Do I want to be low on this estimate and risk the fact that I'm not going to have enough man hours to execute it and I'm going to slip on the project? Slippage meaning that you have an estimated amount of hours that you're going to perform it in, and you come way over those hours, thus you have added costs that is slipping from the original project estimate. Negative slippage is where you have cost overruns. Positive slippage is where you actually deliver it below cost, and that's a good thing. So you're thinking like a programmer. You're going and you are essentially thinking through the flow of this system, kind of our tip in our previous episode, thinking about the flow, but this one you're taking it a step further. And so that is what I want you to do. Now, if you're a technician, obviously you're going to expand on this even further. You're going to really start to think like a programmer. You're going to then move into tip number 2, which is really rearranging if necessary, but without changing. And this is actually quite a difficult skill to master, because anyone could go and rearrange a sequence and say, oh, look, there's that start sequence. It's at the end of the sequence of operations where it actually says how to start the fan. I'm going to go move that to the top because that's where my start condition is in my sequence. And so I'm going to move that to the top of the sequence when I rewrite it. That way, whoever's programming it, or if I'm programming it, that's how we're going to do it. But you got to be careful when you do that, because when you get to complex sequences like chiller plants or multi-fan air handlers with building static pressure tied to the air handler's control, or maybe it's got some resets tied based on VAV units, you can start to have complexity. And if you go and you, for example, let's say this right here. You have a sequence of operations. And the first thing it does is it looks at the VAV box position before it goes and turns on the air handler, because you don't want all the VAV boxes closed before the air handler turns on. Now, I'm completely just making this up as I go, but this sequence still is going to prove a point. You won't see a whole lot of ones where you have to have all of the VAV boxes open, because those are normally set, but go with me on this. So you have this sequence that says, hey, I've got to have all these VAV boxes open, or at least at minimum position, before I enable my air handler. Now you're thinking to yourself, well, I need to enable the air handler, so I'm going to move that above those VAV boxes. Well, therein can become an issue, and that would cause a major problem if you turn on an air handler and all of the boxes are closed. Sure, you'll trip the high static, but it's still a pain in the butt to have to go up and manually reset the high static, which is another side note. Don't use automatic resets on high statics and low statics. But that's neither here nor there. That's a question I got in a forum just the other day, and I wanted to throw that out there. However, think of another scenario like this, right? Chillers with isolation valves. I like to tell the story about how when I started off in this field, I didn't know you had to have the isolation valves open, and I went and tried to turn on a chiller with the isolation valves closed, and that did not work too well. But what if I were to just say, hey, chiller enable, and I put that in front of having the isolation valves on? That could work in some scenarios. In some scenarios, the chiller is going to enable, but it won't turn itself on until it detects flow. It has an internal flow switch. However, in other scenarios, that chiller does not have an internal flow switch, and because of that, what's going to happen is that you're going to go and enable this chiller, and it's going to try to turn itself on, and then it's going to start deadheading, or not having flow. It's not going to deadhead at all because the pumps aren't going to be on. But it's not going to have flow, and it's going to cause it to essentially just lock up and shut down. So you've really got to think through whenever you go about rearranging something. You don't want to change it, but you want to rearrange it. Now, why would you want to rearrange things? Well, the reason you want to rearrange things is that you want to do two things. One is you want to make it easy for the programmer, or easy for yourself if you are the programmer. So that's one reason. But the other reason is, let's say you go with a commissioning agent, and the current way that the sequence is arranged, it's not going to work. It's just not going to work. So for example, the chiller enables before the isolation valves turn on, and you've got an issue there because that chiller is looking for flow. Now, some actual commissioning agents, not all, but some, hold you to the letter of the law of, and I see this. Oh, do I really want to say this? I see this on lead projects a lot, where commissioning agents get selected because of their experience on lead projects and not their actual knowledge of how stuff works. And so I see some commissioning agents who have no clue what's going on, and they read a sequence of operations, and they read it literally, and then they're, well, you had to turn on you had to open the isolation valves before you turn the chiller on. You failed the sequence. And it's like, really, dude? Really? I mean, do you know how this stuff works? And so that's the time when, before it ever gets to that point, you can go and actually rearrange stuff, submit it as an RFI, and say, hey, I really recommend that we open the isolation valves before we turn on the chiller, especially with this type of chiller, which has an internal flow sensor, or does not have an internal flow sensor. So as soon as I enable the chiller, it's going to try to turn itself on. I really recommend that we go and have the isolation valves open first per the sequence, especially since this is being commissioned. And then you submit that up the chain in a construction project, which this is making me realize I really need to go and have another episode about construction projects, because that seems to be a lot of questions I get is the construction process. However, with that being said, that is why, another reason why you would rearrange the sequence, but you're not changing the sequence. You're not changing the fact that you're enabling a chiller. An example of changing the sequence would be where you have a air handler that's discharge air temperature is reset maybe by box position. So you look at box position and you're resetting discharge air, or room temp, or whatever. And because of that, you have this discharge air reset. But you decide that you're just going to have a static discharge air temperature because you don't think resets work. And so you eliminate the reset. I've actually seen that happen quite a few times where folks are just like, yeah, they don't really need a reset. I know the operator of the building. They're just going to get confused, so I'm going to turn off the reset. And that is an example of completely changing the sequence. And that's what you want to try to avoid. At least if you're going to change the sequence, go through the process of submitting the change up through the contracting tier, getting the change approved, and then documenting the change. Now, number three is a tip that this is just supremely important. And I've seen this time and time and time and time again where I get phone calls from folks and they're looking at the I/O, the inputs and outputs, and not at the system. So I've seen this. I'm going to give you three different stories about where I've seen this. The first story was I was working with this person. I'm going to try to not use anything that would identify this person. I was working with this person, and it was a school district, and this school district had this issue with a room. It actually had an issue with a lot of rooms. And the teachers kept complaining, oh my gosh, it's so hot in here, it's so hot. And this guy would go and he would twiddle with the VAV boxes. And he was like, I've disabled the heat. I've unplugged the heat because it had electric heat. I've turned off the breaker to the heat. There's no way you're getting heat. But yep, the space was 80 degrees. And he's like, well, you got to close your window shades. You got southern facing windows. That's why it's hot. They close the window shades. It's still 80 degrees. And he troubleshot and troubleshot and troubleshot. And finally, it was just one day, something clicked in his head where he thought, hey, they got baseboard heat. And he went and checked out the baseboard heat, and sure enough, the baseboard heat was set to full heat. And then he realized that the baseboard heat was not communicating to the building automation system. And so he's sitting there troubleshooting this VAV box, troubleshooting the reheat, and all the time there's this baseboard heat that's heating up the space. I've seen this time and time and time and time again where this happens, and it's because folks don't think of everything that's in the space. Now, extrapolate that space example to this next story, which was this guy had another space that the space was cold. And he's troubleshooting the VAV box, and he's working on it, and he's working on it, and we started talking, and I asked him, I said, what kind of VAV box is it? Well, it's a cooling-only VAV box. Okay. Well, where's the heat come from? Well, it comes from the box. Well, no, it doesn't come from the box. That's cooling-only boxes. Yeah, but we put the air at minimum flow, and that's how we go and we start to cool down or heat up the space because less air. Well, yeah, that's true in some cases. In other cases, you have units that actually provide heat. So I said, what's the unit? And we started talking, and he said, well, the unit has heat. And I said, okay, so what's the heat being used for? Well, I preheat the outdoor air coming in. Okay, so it's got preheat. What else? Well, it's got cooling coil. Okay, cooling coil's closed, so we're good there. What else? Well, it's got a reheat coil. So, okay. Well, what's the discharge air coming off of that unit? Oh, it's 60 degrees. Okay. Are the other spaces all cooled down, or are they warm? No, they're all at set point. So naturally, what do you think most people would do? Most people are going to go and say, well, I need to turn on the heat at the unit because the unit's not getting it's not heating up the discharge air, and the space, it's just not going to heat up. I need to turn on the heat because the heat's going to heat up the space, and so that's why they got heat in the unit. It's a reheat unit. It needs the heat. Okay, so let's do that. But what would happen? Well, all those other spaces that are satisfied, what do you think's going to happen to them? They're all going to get hot, right? Because right now they're at set point without the heat on. I turn the heat on, they all get hot. So right now, the some questions might be forming in some of y'all's heads. And what I want you to do is pause this episode for just a second and kind of think about what would you do? What would you do if you were in this situation? Okay. So you paused the podcast. You came back. I think I called it a video before. You paused the podcast and you thought about this. And hopefully what popped up in your head is the airflow even right in the space? Because we've got to think of the greater system, right? How does the system of airside systems, right? How does that greater system work? Well, we introduce air into the space and we take air out of the space. That air changes allows us to add volumes of air that are either hotter or colder, either removing heat from the space or adding heat to the space. Well, if our points are wrong, if we're providing too much air at minimum, could we be subcooling the space? And so sure enough, that's actually what happened. It was that the minimum airflow set point was way too high, and they were going, and they weren't seeing issues during the summer. And this is kind of one of those indicators that will tell you if your CFM for your heating is way too high, especially on cooling only boxes. Is if you don't have issues in the summer, and during the summer that box sits at like 20-30% when the rest of the boxes are at 60-70%, that's an indicator that your max flow setting is too high, which if your max flow setting is too high, then usually your minimum flow setting is too high. And that's what the issue was. His flow settings were too high, and because of that, he was providing too much flow to the space. So I said I'd give you 3 scenarios, right? So the third scenario, once again, understanding systems, was working on a church, and this church was huge. It was, oh my gosh, I want to say 1,000,000 square feet, but I don't think it was. I think it was like 500,000 square feet. It had 22 air handlers, 3 centrifugal chillers, and a decoupled primary secondary loop. And basically what was happening, so with decoupled loops, essentially the primary loop volume is constant and the secondary loop volume varies. A decoupler is basically a bridge pipe that connects the secondary and the primary loop. And what was happening is that if the primary chillers stage on, or the primary chillers do stage on, and then they add more GPM, that GPM overpowers the secondary loop, and that then pulls water from the primary back into the primary, because the primary is now overpowering the secondary, which now the secondary will start to increase its flow to compensate. It starts pulling more GPM. And this is really something you got to visualize. I'm like visualizing it in my head. I'm like, how are folks going to follow this on audio? Anyways, the key point of all of this is that with the decoupled loop, the loop that has the most flow is going to pull water through the decoupler. And what was happening is that no matter what we did, the secondary loop was not getting enough water. And it was just starving for water. And so we and I'm not proud of this, but we troubleshot that thing to death. I mean, if it was a horse, we beat it to death, brought it back to life, beat it to death, and brought it back to life again. I mean, we checked PID loops, set points, everything. But what we didn't check was the balancing valve on the pump. And it's embarrassing, too, because I know that we'd probably walked by that pump several times, and I know that we probably had heard it, and we're thinking, that pump doesn't sound right. But we were so focused that we didn't think to go, that pump doesn't sound right. Until one day we did. We had all but exhausted what we were doing to troubleshoot that thing, and then we're just like, that pump doesn't sound right. We walked over to it, and sure enough, the pressure drop across the pump was huge because there was such a buildup of pressure and then there was no water getting through because that balancing valve was shut. And I guess during some sort of maintenance or something, the valve was shut, and then an isolation valve was slightly cracked. And all of this led to this valve or this pump not getting enough flow in the secondary loop, which thus it wasn't overcoming the primary's pull on the decoupler, so it wasn't pulling flow to the secondary loop from the primary, and thus all the valves on the air handlers were wide open. I mean, this was nasty. After we got it fixed, we had to go retune loops because these loops had tuned themselves to being wide open. It was just kind of craziness. And the thing is that we thought about a system, but we thought about the software side of the system, not the mechanical side. So as you look at sequences, I really want you to understand the system. What effect do these changes have on the system? Because you'll see some crazy stuff that makes no sense, and you'll be like, man, that makes no sense, but, it's the sequence, all right, whatever. You got to think about the larger effect on the sequence and say something if it doesn't seem right. All right. So those are 3 strategies for dealing with sequences. They are to think like a programmer, even if you're not a programmer, even if you're in sales or you're an engineer, just think about logically, is this complex or is it not complex? Do I have the stuff I need or do I not? Rearrange sequences if necessary, but don't go and change them. So this is important because you want to make sure that things are working in the order they should work. And finally, understand the system and not just the inputs and outputs. This is really important. You don't want to be that person who just thinks about the inputs and outputs and you're so focused on them that you don't think of the greater effect of something happening to the system or in the system. Okay, so if you found these sequence tips helpful, you found my way of digesting sequence of operations, then that's awesome. Realize, though, these are just my raw, unorganized thoughts. I just released, depending on when you're listening to this, Control Sequence Fundamentals, my latest online training course, and it is freaking awesome. It is an amazing course. The feedback from my students has been unlike anything I've ever seen. I mean, this is the course that if I had had this when I was just starting in the field, heck, up to just recently, I learned stuff when I was creating the course. I mean, this course is a game changer. It deals with that issue of, hey, I want to be in BAS, but I don't have a mechanical background. Hey, I'm in sales and I want to better understand sequences so I can better scope my projects. Hey, I'm an engineer and I've just used boilerplate specs from manufacturers up to this point, and I want to take my control specs to the next level, but I don't really know what to do because there's no training out there. If that sounds at all like you or someone on your team, then this course is for you. And depending on when you're listening to this, for this first week, I have a special offer going on that for those who purchase the course during this first week of its release, they can also get 6 modules from my Building Automation Fundamentals course absolutely free. And that is because those 6 modules will really help you understand what is in the control sequence course. So if that at all interests you, if you want to take your career to the next level and you know that your knowledge of control sequences would really help you or your team as you move in to this summer, this upcoming summer of construction, then really you need to take advantage of this course. There's nothing else like it in the market, period. Now, for those of you who want to look at that, or for those of you who just simply want the show notes from this episode so that you can see the timestamps and you can see anything that I've referred to, like, for example, how to get to episode 104, simply go to buildingautomationmonthly.com/105. Once again, that is buildingautomationmonthly.com/105. Now, in next week's episode, I got a really interesting question from someone on Facebook, and they were asking me about how to tie into a BAS system with another BAS system. And they were concerned that they were going to have to rip out one of the BAS systems. And that made me realize that I really need to revisit kind of what are the different devices in a BAS, but in a more advanced way. And what do they do? And how do you know when you need to use them, when you don't need to use them from an integration perspective? So that's what we'll be looking at in next week's episode. We'll unpack how do we go about actually integrating two building automation systems together. We'll look at multiple different ways of doing that, and I'll tell you how I've done that in the past. With that being said, thank you so much for being here. I really appreciate all the comments, all the really awesome reviews. I hear from folks both through Facebook and through iTunes that I'm impacting their career. Thank you so much. I got a great testimonial the other day from Ben, who said he's been in the HVAC trade for 12 years, wanted to get in BAS, but he just didn't know how to make that leap, invested in my programs, and was able to make that leap, and just recently got hired by one of the top 5 building automation companies in the world. So, Ben, that's all because of your hard work. So I'm just glad that I was able to guide you through that process. And to the rest of you, thank you so much for being here. I look forward to talking to you in the next episode. You all are awesome. Keep it up. Keep working hard and learning more every day. And I'll talk to you next week. Take care.